Let's discuss some more questions regarding UPSC ESC prelims previous year's questions. We are going to study questions from the year 2013. The first question that we are having is, if an ideal voltage source and current source are connected in series, the combination has same properties of current source alone, has same properties of voltage source alone, has same properties of sources with higher value, results in branch being redundant. So the answer is A, okay, has the same properties of current source alone. The next question that we are having is, this is your circuit given to you and you have an unknown resistance R. You have to find out the value of resistance R such that the equivalent resistance between A and B is R itself, okay. So as you know, these two resistances are in series. So when you find the equivalent will be in parallel to this 3 ohm and the equivalent further would be in series to this 2 ohm. So the equivalent of this entire circuit will be equal to R, okay. So on solving, get this equation and the answer is 4 ohm, okay. The next question that we have is a bit tricky one, okay. You need to learn this question a bit, okay. This is, what is the number of capacitors required, okay. Each capacitor is having 2 microfarad and 3 volt, okay, as its rating, okay. How many such capacitors are required to obtain a capacitance of 2 microfarad and 1200 volt, okay. You have such options. So what we are having is, for having 1200 volt we need 4 of these, okay. So that 300 into 4 is 1200 actually, okay. 300 into 4 is actually 12. So you need 4 capacitors in series, but you know that very well that when 4 capacitors are in series, the equivalent would be such, okay. So the equivalent of 4 resistance in series would be 0.5, but you need 2. So how many you need? You need actually 4 of these, okay. You need 4 series, okay. I mean 4 sequences of these 0.5, 0.5, 0.5 and 0.5. Only then the resultant would be 2, okay. Because in series when you add 4 you get the 1200, and when you add the 4 branches as such you get the equivalent as 2 microfarad, okay. So the answer is 16. Now we are going to have this question, which is, network has resistance, independent voltage and current sources. The value of its determinant based on loop analysis. First, cannot be negative. Second, cannot be 0. Third, is independent of the values of voltage and current sources. Fourth, dependent on the values of resistance and voltage and current sources. So the answer is 1, 2 and 3, okay. In a network, if a resistance is independent of voltage and current sources, so the answer is cannot be negative, cannot be 0, and is independent of the values of voltage and current sources, okay. The next question that we are going to have is power dissipation, okay. This is your given circuit diagram. I will explain this question in detail in a separate video, okay. But for the time being, what we are doing is, this is your question and these are your options. So they are asking you the power dissipation in this particular circuit element over here, okay. Controlled source, this is a dependent source. What we do, we apply your KCL over here, simple, and then we solve this, okay, and you get the answer. Then the next question is this one. I have a separate video on this already on my channel. I will be linking this video in the description box, okay. The question is, this is your required circuit diagram and they are asking you the value of resistance across RB, BY and RY, okay. The thing you need to visualize is that this is a delta, okay, and this question is based on star delta. And if you have any problem regarding star delta, you can check out my previous videos, the link is in the description box, okay. Detailed solution of this question as well as things regarding star delta connection, both of those videos will be linked in the description box, so make sure you check the description box and the video as well, okay. This is all for this video.